Today's video is about 3F, which is prime decomposition. To understand today's content, you have to know what a prime number is. A prime number is a number that can only be divided by 1 and itself. Examples of prime numbers are 2, 3, 5, 7, 11, and so on. So prime numbers only have 2 factors, 1 and whatever the number is. You really need to keep that one in mind because we are breaking down composite numbers today. Composite is the opposite of prime, so they have more than 2 factors. We're breaking composite numbers down into their prime components. That's what decomposition means, to break it down. So our key idea is that every composite number can be expressed as a product of prime numbers. So composite numbers, numbers that have more than 2 factors, can be expressed as a product of prime numbers. Now, product is a buzzword for us. What does that product word mean? Hopefully you remember that it means multiplication. So what that means and what it looks like is we are going to start with a number. This whole idea is called factor trees, and hopefully you've seen something like this before. So I'm going to put up the whole example here, and you can have a look and see if you can figure out how to do it. So we have a factor tree. It starts with a composite number at the very top of the tree. So the composite number I've chosen here is 48. Then we have 2 branches that come off that factor tree. What we are doing is we're looking for 2 numbers that multiply to give the number at the top of the tree. So I have selected 24 and 2. And that's a pair of branches. Now, my 2 is circled, but my 24 is not circled. My note in green says, when you get to a prime factor, you need to circle it. That circling tells me that branch is finished. I don't have to keep going here. 24 I did not circle. That's because 24 is composite. It has more factors that I can break it into. So I'm going to break it into 6 and 4. 6 and 4, neither of them are prime. So I'm not going to circle either one of them. I'm going to continue to break them into their prime factors. 6 goes into 2 times 3 is 6, and 4 gets separated into 2 times 2. So I have circled all of the factors that were prime. And you will notice then my second last step is to say 48 equals 2. So I covered all my bases. It equals 2 times 3 times 2 times 2 times 2. So any number that I put inside a circle, that's what goes into my final product. All right, and you could actually figure that out by doing the calculation in your head. 2 times 3 is 6, times 2 more is 12, times 2 more is 24, times 2 more is 48. So that is correct. And you will notice my final step is to use our powers knowledge from last term to simplify it. And we always try to start with the smallest base number. So my base numbers were 2 and 3. 2 is the smaller one, so I've started with that first. Now, some of you may have thought up the top, oh, I probably wouldn't have divided 48 like that. Maybe you want to divide 48 with 6 and 8. Okay, that's fine. You can do it however you want to. The beautiful thing about a factor tree is that we will end up with the same answer. It doesn't matter how we get there, as long as your multiplication facts are correct. 6 I'm going to separate into 2 times 3. Both of them are prime, so they go in circles. 8, let's divide 8 up with 2 times 4. 2 is prime, but 4 is not, so it does not get a circle. And I continue breaking that one down into 2 times 2. So then I would write 48 equals 2 times 3 times 2 times 2 times 2, which equals 2 to the power 4 times 3. And you will notice that when I have a look at my earlier solution, even though the factor tree looks different, my final answer is the same. Okay, what I would like you to do now is try 60. Can you break 60 up? What numbers divide into 60? Go ahead and try and make a factor tree And then you can come back to this video and see if you got the answer right. Options to divide up 60. I think that the probably most obvious one in my head is to go for 6 times 10, but for you it might be different, and that's okay. Remember, we'll get the same answers. They're both composite, so they need to be divided up further. 6 is the same as 2 times 3. 10 is the same as 5 times 2. So my final step is to write 60 equals 2 times 3 times 5 times 2, which I will write with some powers here because I've got 2 times 2 is 2 squared, and the remaining numbers were to the power of 1. And if you're feeling particularly fancy, you can also do this. Those 3 dots there, and they just mean the word therefore. Alright, so therefore just is represented by those 3 dots there. And again, you could have done your factory completely differently. You could have said, oh, well, I want to do 12 times 5. That's fine. 12 is 3 times 4. And then we get 2 times 2. And what do we get? We get 2 squared times 3 times 5. It does not matter how you do it. Here's your last one, 220. Find that in the prime factor form, please. Alright, it ends in 0. That is a good hint to me that it is divisible by 10. 10 is divisible by 5 and 2, which are both prime. 22 is divisible by 2 and 11, which are both prime. Sorry, I'm writing those as circles, but really they should be more like dots. Therefore, and we say 220 is the same thing as 5 times 2 times 2 times 11, which equals 2 squared times 5 times